Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today we have a special interview recorded by Fred Schenkelberg in January 2016 at the Rams Conference in Orlando, Florida. Fred's guest for today's interview was Gerry Cohen, Senior Reliability Engineering Consultant at Ops A La Carte. Gerry has over 40 years of experience managing quality assurance, reliability engineering, supplier management, customer field support, and application engineering for small and large high-tech organizations. He's worked as a corporate director, senior manager, and principal engineer. Gerry's expertise includes SPC, applied statistics, reliability engineering, design for Six Sigma, design for manufacturability, design for reliability, design and process FMEA, and training and coaching of green belts, black belts, and Kaizen teams. Fred talked with Gerry about consulting and reliability engineering in general. Let's join Fred's interview with Gerry Cohen.
All right. Welcome to Dare to Know. This is Fred Schenkelberg, and today I have the great pleasure of sitting down with Gerry Cohen. And I know that you're in consulting now. We've run our paths across that a couple of times, but you've been in the industry for a few years.
For a long time.
For a long time. I'll let you phrase that.
So after a stint in the U.S. Air Force, where I worked on high reconnaissance aircraft, I started in semiconductor for the first part of my career.
Oh, wow.
Making hybrid semiconductors for the space program.
Okay.
So we made hybrids, ceramic hybrids, high reliability ceramic hybrids that went into the Gemini, the early.
Wait a sec, you're really going back in time. The Gemini was in the 60s, wasn't it?
So we did quite a bit of work with the Air Force, with the Defense Department, and I actually learned a lot about process and how to put from green ceramic all the way down to plating a semiconductor so it can be utilized in that fashion. But from that point, my career took off, and I eventually went into mini computers, and then in peripherals like disk drive and tape drives.
Were you always in reliability through this, or was it more on process development?
I was in quality assurance and reliability.
Okay.
Well,
how would you separate the difference between those two? Because I've seen people confuse those, or maybe they are really interrelated.
Well, a lot of my early career was spent with suppliers and supplier qualification.
Okay.
And trying to get suppliers to work with us, and trying to get, especially with printed circuit board, with multi-layer board manufacturing. All these semiconductor application that had to have a suitable supplier to provide us a platform so we could manufacture those boards with high rail components, and also high rail printed circuit boards. So a lot of my early career was spent on the road qualifying suppliers that had 15, 16, 17, 18 layer boards that we could utilize. So that's where I started. But later on, I became a director and a corporate director of quality and reliability.
Okay, so you had both
umbrellas.
I
was both the engineer, and I was both the manager and the head of the quality and reliability department, as much as also Lean and Six Sigma application. So I became a Six Sigma black belt, and had a lot of lean team under my jurisdiction. That also allowed me to put some of those tools into effect.
Well, so how long did it take from when you came out of the Air Force and started that work to becoming the director of quality and reliability?
Only 40 years.
24?
40.
40 years, okay. So you've seen some trends come and go. You mentioned like Lean Six Sigma. Is that a trend, or is that going to stay?
No, I think Lean Six Sigma or Lean Enterprise, which some people call, is as a place into our industry and our sciences. And I believe that the way that teams function, if it's done properly, can bring a lot of value to any organization. For example, every Friday night, we had a walk around in the factory in Mexico, in Tijuana, where we actually went from station to station, and there will be an individual there waiting for us to present how the week went as far as rejects, as far as P chart or U chart or a X bar in our chart. And he would actually present the result of his weekly run, and that was very, very, very positive from several points. Is that allowed an individual on the line to present his result, and it gave us a chance to see how things were going on the floor, which is, I think, is very, very powerful.
Well, you see so much of the automated assembly processes now, and where there's not an operator for each machine. They're spread out over, they might be managing the entire line, and then we just automate the data collection. Are we missing something?
Well, the human value is missing, right? Where the individual that is responsible for the line sometimes is invisible, right? It could be a robot. It could be another state.
But so what do we lose by that? We're still collecting data.
I think we're using the human factor where someone can actually add value with the way he or she works, the way he or she approaches a certain process.
Well, and you know this, is that when you have an out of control situation, it's as much by being aware of any anomalies or any factors that could have created that, either good or bad.
Right.
And the robot will collect the data, but a human needs to notice what's different. And we're good at that.
Right.
Whereas a data collection device collects the data.
As long as the data is actionable. That's one of the problems that we have, is a lot of the data is not actionable. It's just data to have data.
Yeah. You've seen buildings full of data, I'm sure. it's just, yeah.
He just keeps moving different places.
Well, you've been into a number of suppliers and stuff. How do you know that they're creating a reliable product for you, or a reliable component, say?
For suppliers, we eventually, in one particular company, we put together a very powerful supplier certification process that involved not just qualification, but a whole set of deliverables along the line that allowed us and the supplier to team up and to measure certain criteria. So the supplier and us were in fact working together toward the end of the line, which is the qualification and the ship to stock or the ship to line process.
Right.
So the ultimate thing is you don't want to inspect anything anymore because there's just no time and there's no money and there's
well, it also creates damage too.
It's a waste of time, and you created more problems sometimes.
Right, oftentimes.
So we want, this is some years ago, but still this is still very valid. Is you want you and the supplier to work as a team. You want to know him. You want him to know you, and we teamed up with the suppliers in many cases where the suppliers and us, we invited suppliers to come in and to be with us and to see how his spots were integrated into the process. And that was very powerful as well, because it allowed us to team up and to understand each other's variable.
Right.
Same with the customer. Some of our customers were IBM, Motorola, Texas Instrument, the biggies. And what we did for our application engineering department, we actually got equipment from them. And we installed the equipment in our lab. And we tested our devices on their equipment to actually experience what they would experience.
Right.
And we learned a lot, including the flaws on their equipment.
Yeah. Yeah, you probably have to be a little careful about how much you report.
Watch what you find out.
That's right. But it's one of the disconnects oftentimes in the design or the manufacturing process is, well, how's the customer going to use this?
Right.
What are their requirements? And just having that discussion sometimes is really helpful. But, actually seeing their plant or their machine goes a long way.
Absolutely.
Now that's expensive. How did you justify doing stuff like that?
We negotiated with the customer.
Right. Okay.
Yeah.
So it really is a partnership.
We had an enormous lab with I bet you 20, 25 pieces of equipment that came directly from the customer. And they were glad we did, because they said, then you can tell us exactly how our devices, in this case it was a tape backup device,
Right.
how it behaves in our system before we even get it.
That's right. And so you it's like a beta program, but it's in your facility.
Absolutely.
Yeah.
Absolutely.
Now, that's not the only way to do qualification. So, I mean, there's all kinds of different techniques. So, do you have a favorite way to
Well,
approach?
we had I believe we had a very, very thorough qualification process. We broke it into three parts. We had an engineering verification test process, which was led by the engineering group by themselves.
The engineering being the design development teams.
Group.
Okay.
Yeah. This was followed by a DVT, design verification test, which involved engineering, quality, reliability. Now you have a team of people working together, and it's the next level of qualification.
Okay.
Or you do margin testing, for example. You might want to do halt at that particular stage, or you may want to do shock and vibe, and all those things that DVT usually does. And then we have a third level of qualification where the product was more mature, called PMT, which is product maturity testing, which is included also the tooling, and also all the different elements of human factor, ergonomics, operator knowledge and certification, and so on and so forth. Especially if you have a factory overseas, where you're creating tooling in the U.S. and it has to go overseas. All of a sudden, there's a big delta there. So the qualification of tooling in the U.S. and in overseas is a very important step.
Yeah, and that's where we used to call it as we ramped up, and we worked really hard to get it on the actual production equipment.
Yeah.
Yeah. And I mean, were these all pass-fail criteria? I mean, halt test obviously is not, but would you just test a certain sample size and call it good, or do you use other techniques?
We tested in different ways. One of the big strengths of this particular enterprise was the inclusion of ORT, ongoing reliability testing. ORT was a very powerful tool for us. We use a PRIS chart. We had sample taken twice a week. We ran those samples for many weeks. And we learned a lot about reliability from those samples in the ORT process.
Any particular circumstance that you were paid for the ORT?
Well, the circumstances is that we were able to find many different errors that would have been included in the product later on that we found in ORT that people wouldn't believe. So it was like I say, a very powerful test for us, as well as reliability demonstration testing, which we did about 3 or 4 times a year.
Okay, and so it'd be pulling units off of your current production essentially,
right.
and
Exactly,
and go off and show that you're still there. Because, as you know, the materials change, the processes update, vendors change components, and
a major ECO, for example, is introduced, engineering change order. Well, if you change something drastic in the product, how are you going to know what it's going to do?
That's right.
You've got to put this. You've got to put either a demonstration test together or growth test together, or test it into the ORT to see how it behaves, and appreciate the delta between one and the other.
So, what have you seen as trends in our industry, is concerning whether it's testing or qualification work, or what have you seen over your career as?
Well, the trend now is speed. Is trying to get to now knowing how the product is robust faster than before.
Right.
So HASA, which is an audit process, is now being used a lot, versus HAS. Rapid design application is robotics, design tools. Robust design, some of the things being used now.
Right.
So what we used to do in 4 to 6 months, now it's 4 to 6 weeks, right?
Right. And the tools are getting better.
The tools are getting better.
And stuff. Now, has the attitude towards reliability changed in your experience?
I think it's more appreciated now. I think it's something that has come out of the early people in reliability is people you never talk to. they were in the lab somewhere and you didn't want to talk to them.
That's right. They did the failure
They
analysis.
did the failure analysis.
That's about it.
Don't bother me. The reliability folks now, I think up front, I think they're being recognized as having high value, and I think they are a key in producing knowledge that makes things better.
Right.
And safer.
And safer. Yeah, and I've heard that from a number of folks on this Dare to Know show, is that a lot of what we do is focused on making things better. And if you're not, you need to rethink what you're working on. Yeah. So what would you advise, say, somebody getting new into the field of reliability? How do they start a career or build a career? And it sounded like you came in through quality assurance and it grew. Responsibilities.
1970, I've been in this business.
A few years. Right. But given today, there's so many tools, there's so many ways to learn the program.
My advice would be for anyone that wants to get into this business, is get real comfortable with applied statistics and know your statistics inside and out.
Mm-hmm. So that's more than just the normal curve in SBC.
It's just more normal
the
curve.
Whole thing.
It's you were talking about normal curve theory, but also you were talking about t-tests, f-tests, chi-square tests, design of experiments, both Takuchi and classical. Talking about knowing how to manipulate data and to understand what data is telling you.
Right.
Being comfortable with data. And I would start there, and I would certainly would appreciate someone that has a curiosity for life sciences, knowing about how things fail, why they fail, spending time in the lab. I think people that spend time in the lab have a different appreciation than people that don't.
That's right.
Because you get to touch and feel what it feels like.
And see what actually happens and examine
failures.
Experience it.
Right.
Yeah, that's unfortunately, you don't want your vehicle or your car to get to work to be your experience, unless you're in the auto industry, I guess.
Exactly.
But now you're in consulting. How long have you been consulting?
About 5 years.
I thought that was longer than that.
Well, I was still working.
Oh, okay.
I was still working part-time, and then I met Michael many years ago. Actually, he came to visit us, and you may have been part of that visit.
Might have been.
At the Capstone Turbine, and back
in
2004, 3 or 4.
Yeah, I did some work with you guys.
And so it was way back when. We became friends, and when the time came and I was available, we started working together probably around 2006 or 7.
Okay.
So it could be as much as 10 years.
It is almost 10 years. I thought we've known each other a while. It goes too quick, doesn't it?
Flies.
Yeah, it does.
So it's been good. I work about 20 hours a week. I do some webinars, from time to time. I'm about to present a paper late in the week.
Oh, what's that on?
It's about the application of two stressors in reliability qualification.
Okay. All right. Yeah, I'll have to check that out, and we'll link to it in the show notes.
Absolutely.
So, do you have a website or other ways people can get in touch with you, or what's the best way to get in touch with you?
The best way to get in touch with me is through my email.
Okay.
Which is gerryc@opsalacarte.com.
Okay. We'll add that to the show notes and link to it. And
be more than happy.
Yeah, and I have known through the years that you're more than willing to answer questions and provide feedback.
My pleasure.
All that good stuff. You got a wealth of experience. It's hard to replace unless you have 50 years to go do it. So you got any plans? I mean, you're presenting later this week at the conference here at Rams. You got any books in the works or other projects in the works you want to plug a little bit?
We're working on a book on green reliability, and I'm working on that.
Okay.
Trying to help a group of people here put that together. So that's kind of fun, trying to do some research. I did spend some time with Fisker, which is one of the early electric cars that didn't do so well. I'm fascinated by Tesla and also by Toyota. Their effort, I think, is paid off. Tesla is successful, or we hope they're successful.
Right.
Even though not cheap. But I think that's the next. I think then the next set of challenges is going to be batteries.
Well, Samsung knows about that. That's for sure. It's amazing, though, how much power density we can get in these small form factors, and more and more applications all the time. And vehicles are kind of on the high end of that. But you're exactly right. There's still, I think it's one of the things that makes reliability engineering so fascinating is that we're the scientists and engineers are creating new materials, new processes, new applications all the time.
Correct.
And we get to ask the same questions. Well,
Right.
Is this robust enough? Will it last long enough? And learn stuff every year.
And I'm also kind of intrigued by the application of rare earth elements into magnets and so on and so
Right.
forth, and how some of those rare earth elements might be influencing some of the battery manufacturing process.
Yeah, you might have. So if you want to work on batteries, give Gerry a call, especially the reliability of them. Sounds like a very needed specialty at the moment.
Absolutely.
Yeah, definitely. Well, thanks so much, Gerry, for stopping by. And
My pleasure. Always great to see you.
Yeah, thanks. Appreciate it. Talk to you later.
Yeah.